Sequences as functions. A sequence in mathematics is a collection of numbers, symbols, or objects that are ordered and follow a particular pattern. Individual values of a sequence are called terms and are identified by the position in the sequence. Here are some examples of sequences. 1, 3, 5, 7, 9 is the sequence of positive odd integers. 1, 4, 9, 16, 25 is the sequence of square numbers. Triangle, cube, pentagon, hexagon is a sequence of geometric figures. The sequence of figures fit together to make a large square. Slide the green circles to the left, like this. Count the circles in the nested squares each step along the way. So we start with 1, then we have plus 3, 1 plus 3. Then we have 1 plus 3 plus 5. Then we have 1 plus 3 plus 5 plus 7. And finally, 1 plus 3 plus 5 plus 7 plus 9. Addition simplifies the sequence term by term to a recognizable pattern. Simplified, the sequence is given by 1, 4, 9, 16, 25, and so on. The first term is 1, the second is 4, the third is 9, etc. Imagine more circles and squares to extend this idea. What would be the 10th term in the sequence? Is 225 in the sequence? If so, which term in the sequence? The 10th term would be 10 squared, which is 100. 225 is in the sequence because it is a perfect square for the number 15. The sequence of figures fit together to make a triangle. First, we slide the green triangles over, so we get 1 plus 2. Then we have 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, and 1 plus 2 plus 3 plus 4 plus 5. Simplified, the sequence is given by 1, 3, 6, 10, 15, and so on. The first term is 1, the second, 3, the third, 6, etc. Imagine more circles and triangles to extend this idea. What would be the 9th term in the sequence? Is 78 in the sequence? If so, which term in the sequence? Here's how you can model this sequence. N times n plus 1 divided by 2. So for example, the 9th term would be 9 times 10, 90 divided by 2, which is 45. And we can solve this equation for 78. We see that n would be 12. A sequence is a function usually written in set notation, where a1 is the first term of the sequence, a2 is the second term, a3 is the third term, etc. Typically, the domain is the set of natural numbers, 1, 2, 3, etc., where n, an is a point on the graph of the sequence. The range of the sequence is the sequence itself. A sequence in list form looks like this: 1, 4, 9, 16, and so on. A sequence in function form would look like this: n squared. A sequence in table form would look like this. We would have the n values, so the term, the number of the term, so like the first term, second term, third term, and then a sub n is what that term in the sequence actually is. Shown here is the sequence given in graph form. So the first term is 1, the second term is 4, the third term is 9, and so on. Example 1. Consider the sequence a sub n, the square numbers, where an is 1, 4, 9, 16, etc. Its rule is given by an equals n squared. What is the domain of an? What is the 10th term of the sequence? Evaluate a20. Given an equals 256, solve for n. And what is the range of an? The domain are all of the natural numbers. The 10th term, we just plug it in the formula, we get 10 squared, which is 100. A20 would be the 20th term. 20 squared is 400. Solve this equation. What's the square root? Take the square root of both sides. The square root of 256 is 16. And the range is the sequence itself, 1, 4, 9, and so on. Consider the sequence Bn, the even natural numbers, where Bn equals 2, 4, 6, 8, etc. Its rule is given by Bn equals 2n. What is the domain of Bn? What is the 10th term of the sequence? Evaluate the 23rd term of the sequence. Given that Bn equals 500, what is n? And what is the range of Bn? All right, the domain are all of the natural numbers. The 10th term would be 2 times 10, which is 20. The 23rd term would be 2 times 23, which is 46. Given that Bn equals 500, that means that n must be 250. And the range is the sequence itself, 2, 4, 6, etc. Consider the sequence Cn given by Cn equals 1, 1/2, 1/3, 1/4, etc. What is a formula for Cn? What is the 8th term of the sequence? Evaluate C36. Given that Cn equals 0.001, solve for n. And what is the range of Cn? Well, the formula is just going to be 1 over n. The 8th term, therefore, would be 1 over 8. The 36th term is 1 over 36. Since Cn is 0.001, which converts to 1 over 1,000, that means that this is the 1,000th term. The range is all of the values, 1, 1/2, 1/3, 1/4, etc.